I want to continue to show you some of these slice mechanics, and one cool way of doing that is to also understand and learn about strings. And there's some other things that we can talk about that we haven't already as well. So let's dive into some code. Now, what's interesting about strings in Go is everything is based on UTF-8. And the UTF-8 character set is really a multi-tier character set. It starts with bytes, turns into code points, and then code points turn into characters. But if you ask Rob Pike what a string is, he'll say it's just bytes. And really, that's what strings are. What's nice is that the compiler, and we have packages that know how to interpret those bytes as UTF-8. And it becomes important that you're saving your files as UTF-8 too, or those hard-coded strings in your code may not print exactly the way you want them. But let's go through a little code and we'll learn more about all this stuff. And we'll start on line 38. Now on line 38, I have a literal string. And remember, a string is a two-word data structure. And what's interesting about this string is that it's going to be 18 bytes in length from beginning to end. And a string is just an array of bytes. But what's interesting about this array is that we have some Chinese characters in there. And these Chinese characters require 3 bytes of allocation for that character to be represented. We need 3 bytes for that one code point to represent this one Chinese character. And the max that we would ever need in terms of bytes is 4, because code points are int32 or 4-byte integers. So what's interesting here is that the first 3 bytes of this backing array of bytes is going to be for the first code point and character. The next 3 will be the next Chinese character. And then since everything else is in English, they'll just be 1-byte allocations all the way up from 0 to 17. Pretty cool. Now, remember that as we go through this code. Now, the next thing I'm doing is on line 41. And on line 41, I'm declaring an array. Notice there's a value inside those brackets. And that's going to be an array of 4 bytes. Remember, we have a constant there which is telling us what is the maximum number of bytes we need for any UTF-8-based code point, UTF-max. That's going to be 4. But I want you to understand that this is an array. This is a string, right? That is an array. Now, on line 44, we're going to range over our string. Again, when we do this range, what are we using? We're using the value semantic form of the for range. Why? Because this is a collection of bytes. A byte is a built-in type. We use that value semantic form of the for range. Data semantic consistency all day long. And this time we're going to get the index position, and we're going to get a copy of the code point. So when you range over a string, we're not going to range by byte. We're not going to range by character. We're going to range in that middle ground by code point. And Go has a special type called rune, which is really an alias for int32. And that represents the 32-bit or 4-byte code point value. That's what we're going to be ranging over. So let's go through this code as we range over code points and see what we're able to do with that. So on the very first iteration here, let's use our right here, I is going to be 0. All right, we're going to be starting here at 0. All right, the rune is going to be whatever that code point is for that next character. And on line 47, if you notice what I've done here is I've gotten that code point value, and I've asked the UTF-8 package, what is the length or the number of bytes that we need to represent that code point value we got on the iteration. And in that case, our rune length will be 3. It's going to represent, in that case, these 3 bytes. OK, great. Then I set up an SI value, or string index value, which is I, which is 0, plus RL, which is 3. So I've set up these 3 values right there. I now know my rune length. I know my index position where we're at. Right now we're indexing in here. And I know what my string index is. Now look at what I've done on line 54. I'm using the built-in function copy. And copy takes a destination and then a source. Now, the only destination we can really use for copy would be a slice, because slices are the only data structure here where we can write into. But we can use a slice and or string as the source, because again, a string is really, it's similar to a slice, right? But it's a built-in type, and it's got a backing array of bytes, so we can use it as a source. Now, what's also interesting about strings is we can essentially slice a string. And if you look at what I'm highlighting here, we are doing just that. We're slicing our string. But when we slice a string, it's going to end up creating a new string value. Remember, strings are immutable, so we can't be creating a slice value here. But when we do that, what's going to happen? Well, we're saying create a new string where we're starting at index 0, right? Index 0, okay, beautiful, right here. And then what is the length going to be? Well, 0 through SI, right? And that's going to be 3. We're going to have a length of 3. And so now what we've done is we've created a new string value right there, right? In the scope of the copy call, it will stay on the stack. And now we have a string that lets us iterate just over the first code point. And then we're going to tell copy those 3 bytes into an array. But we have a big problem here. Remember something, the copy function only works with slices. I don't have a slice, I have an array. And you might notice that I'm using that slicing syntax on an array. You know, one of my most favorite quotes in Go, one of my most favorite quotes is this: every array in Go is just a slice waiting to happen. I love that. And that's exactly what's happening here. By using the slicing syntax across the array, what we're going to end up is, in the scope of that call, also constructing a new slice value. But what's brilliant is we're going to be able to use this array as our backing array. So the backing array technically has already been pre-allocated, hasn't it? And what we're going to say is no value before or after the colon. So this is going to say 4 and 4. So now what we're doing is we're telling copy, take these 3 bytes as our source. There they are. Take these 3 bytes as our source and copy them into our array by converting that array into a slice. Every array is just a slice waiting to happen. I love that. OK, and then from there, what do we get to do? In there, I get to start displaying index position. I get to display the rune value. I get to display what it looks like in terms of a character. And here we are again, turning that array into a slice. But this time for the display, what I'm saying here is, let's create a new slice value, again, where it starts at the beginning, but its length is going to be the rune length, 3. So in this case, even though there's a backing array of 4, right? Even though there's a backing array of 4, we're going to set the length to 3, and that's all we're going to print. Now, when we iterate one more time, what's going to happen? Let's change these numbers out. What is I going to be on the next iteration? Well, it can't be 1 and it can't be 2 because we've already processed those bytes. So 0, 1, 2, it's going to have to be what? It's going to have to be 3. It's going to have to move to the next code point in the string. And we know that these 3 represent the next Chinese character, so that's going to be 3 as well. And that means our string index is going to start at 6. So now let's walk through it again. We go back to the copy, and the copy says, great, create this slice value again for the entire array. There we are. But now our string index says, start at I. OK, no problem. If we're going to start at I, we're not going to start there anymore. We're going to start here. Let's use that blue. We're going to start here. Beautiful. That's where we want to start. That's where the next code point is. And then we're going to have our rune length again there of 3. There we are right there of 3. And we're good there. If we go back to the copy for a second, though, we're going to start that index again at I. But this time we're saying SI. Remember SI. What is SI? SI says 6. It's saying go from index 3, right? 4, 5, 6, not including 6. It will just be those 3 bytes. Boom, we're good. And now we copy these 3 bytes into our array, and then again our rune length. After that, everything's going to be by 1. And if I run this code, what gets super cool is we can actually break this string down code point by code point, where it is in the index in terms of bytes. I can even look at the hex values here of those bytes, and we could see every character kind of broken out by code point. Again, what we're looking at are ways of being able to slice Again, slices, I'm slicing strings, right? I'm converting arrays also into slices. All of these really cool things that you can do in Go, because again, at the end of the day, that string and that slice is the core data structure. It drives everything that we do. We want it to drive everything we do because we get the most mechanical sympathy out of this data structure. And this is a data structure that I really want you to spend time learning because you're going to be using it more often than not.